Okay, so we are arriving to the last talk of this workshop. And so I am introducing Svetlana Cook, who is the speaker now, and who is an educational researcher at the National Foreign Language Center at the University of Maryland, where she is a second language acquisition specialist. Her research focuses on the bilingual multilingual mental lexicon, and at the National Foreign Language Center, she is also part of a large research team working on connecting the research on second language acquisition with recommendations for policymakers in the area of multilingualism and language education in the USA. And so today she is talking to us about her model, or about the hypothesis that is called the Fuzzy Lexical Representation hypothesis, and about the implications for L2 processing in a more open-ended fashion. So thank you, and join me in welcoming Svetlana Cook.
Thank you so much for having me here, and it is an honor and a privilege to be invited to such an event, and it's a pleasure to be a part of this expert group of linguists who share my passion about lexical access and lexical representations. So thank you for having me here. Thank you, Isabel, for organizing it. Thank you to Imara for hosting us, this wonderful event. So without much ado, we'll move on to the Fuzzy Lexical Representation hypothesis, which is an amalgamation of all of the research, not all research, some of the previous research that I've been doing over the past about 15 years, and kind of trying to get to the core of what fuzzy lexical representations are, and why are they fuzzy. So here's the overview. Yep. So I'm going to start with talking a little bit about specifics of L2 lexicon. Then I'll talk about possible reasons for why there's differences between L1 and L2 lexicon. Then I'll discuss some claims of the fuzzy lexical representations hypothesis. Then I present some empirical evidence, and then we'll just kind of talk about all the different things that make L1 and L2 lexicon different in their structure and in the way lexical access progresses, the processes take place in L1 and L2, and how fuzzy lexical representations contribute to differences in processing. So why do non-native speakers experience persistent challenges in understanding speech? And I think we all heard enough about how bad non-native speakers are at perceiving minimal contrasts, right? Difficult minimal contrast. There's an abundance of literature, and the list goes on. We also know that non-native speakers have smaller lexicon sizes, but also they demonstrate lexical confusions in their speech production and speech perception. They show different lexical association patterns based on word association studies predominantly, and they also show exaggerated frequency effects. And even more, they show slow processing speeds in lexical access, in divergent non-native processing outcomes, like, for example, different outcomes in priming results, reduced competition, phantom activations. That's all of the things that have been mentioned, but I'm going to talk about it a little bit more. So what are the fuzzy lexical why are L2 speakers show more evidence of fuzzy lexical representations? First, of course, is phonological encoding. As we were talking about over the past days, L1 put certain constraints on auditory processing that are difficult to overcome without training, right? Or without more input, more practice, more experience, and so on. So that's one part, and it's been extensively covered in literature. But we also know that there are changes in neural plasticity. As we grow older, our brain is more resistant to changes. And when we talk about L2 learners, we usually talk about either adult learners or post-pubescent learners. So that's the period when language learning starts to be really, really difficult and really complicated. And primarily, well, not primarily, but it coincides with the critical period hypothesis that the older you get, the harder it is to learn the language and pretty much learn anything, any skill. A third reason why second language lexicon is different is because the new L2 forms are primarily, at the initial stages of development, they're mapped on existing L1 semantics. And in order to do that, there should be new mappings that need to be established. And, C point above, mapping is difficult because there's plasticity issues. So those connections, the new connections, they're fresh, they're not entrenched yet, and they're not as fast because they're new. So it's almost you can think of small walking paths in a city where there are paved roads. So you have to figure out a way how to fit in those walking paths on the map of the city. That's already been taken and built, and all the roads are there. And fourth issue could arise when there are certain concepts that need to be added to the second lexicon that do not exist in the first lexicon. So I'm going to review three of the main claims. So there are two that are direct consequences, and one kind of indirect consequence, I guess. So the first claim is non-native speakers operate with fuzzy phonological representation. So I think we'll pretty much establish that. However, those forms, the fuzzy phonology is not just limited to specific contrast, but it's also can be expanded to the entire word form, because L2 learners don't have enough experience with the word, So, and it's something that like Miriam talked about yesterday. If you hear like a new name, it's hard to remember a new name or last name because you have to kind of figure out what it sounds like, then you have to remember it, you need to hear it repeated several times. So it's a very similar process that L2 learners are going through when they acquire second language lexicon. And this idea is also related to Perfetti's lexical quality hypothesis. So it's the same thing that happens in less proficient readers. So they also don't encode words the same way as high proficient readers does. So again, we're going back to there are certain similarities in the developing lexicon. If it's not very efficient, then it displays very similar characteristics across different populations. The second claim is that fuzzy phonological representations lead to fuzzy form-to-meaning mappings. And this is, again, it's related to the fact that fuzzy representations, they're not compact, they're not functionally, they're not easy to manipulate. So they resist consolidation, and there's some evidence about that. It's hard to transfer fuzzy representations into long-term storage. So when our L2 students struggle with encoding, of course they're going to have an imprecise or very approximated storage representation of that specific word in their long-term memory. And the last claim is kind of an extension of a previous, is that fuzzy semantic representations contribute to fuzziness in mapping and slower retrieval. So because those representations are fuzzy, it's hard to manipulate them. the representation is very, I don't know how it's kind of like spread out activation. It's very inconcrete. Yes, selective. Yeah. So it's hard to access the representation that is newly established, non-specific, and kind of spread out across a larger representational space. And this is because we know that L2 learners have difficulty accessing semantics, and I mentioned that before, that there's this L2 lexicon maps on L1 lexicon first. That's why those connections are weak, they're slow, and it's kind of like dial-up internet compared to high-speed internet of the first language lexicon. So it's there, but it's very slow. And also there are, again, new concepts that need to be created. So we did discuss the problem with representation of phonological forms. And we see them in many different signs. So here's another sign for you. I'll share it. So I think the topic we've covered extensively in this group and in the previous talk, so I'm not going to spend too much time on that. So let's move beyond difficult contrasts. So if we assume that the initial stages of acquisition of a new word form is holistic, and we do have that the same support from L1 studies that children acquire their initial representations in a Gestalt fashion. So it's one form sounding without differentiating the phonemes. They're usually illiterate at that point in time, so there's no reliance on orthography. So it's just one chunk of sounds. And lower proficiency learners, they're at the initial stages of acquisition, so they kind of have to deal with the language the same way that L1 learners do. But even worse, they don't acquire it the same way, so those connections between the phonological form and lexicon are very weak, so they have to work a lot on that. So we can hypothesize if non-native speakers are dealing with that holistic representation that lacks fine grain, it would be really difficult to hear and recognize the word and compare it to what I have. So that comes to the question of, is it the problem of representation or is it the problem of processing, right? So here's just kind of an example. So let's assume that our L2 speakers, this is what they hear on the top, and this is the representation they have at the bottom. So they cannot quite hear what's out there. At the same time, they cannot quite differentiate and specify what's in there. Can you try to find differences? There's 10 differences in there.
There's one strawberry missing.
Okay.
One cherry.
I'm not going to torture you. So this is what native speakers see and hear. Is it easier to compare? Is it easier to identify those difficulties? Of course. And so this is kind of the challenge, like a visual representation of the challenge that non-native speakers are dealing with. So we decided to test, it's not showing. We decided to test phonological priming in Russian-speaking learners using manipulating Levenstein distance, which is the number of substitutions between two words. If you take, for example, map and maps, so that's an addition of one phoneme. So this is a manipulation of one Levenstein distance. If you take map and, I don't have a good example, mango. for example, that would be 4, right? So it's just depending for a distance you find any substitution. You can count substitution, deletion, or addition of a phoneme. So we manipulated Levenstein distance, and unfortunately it's not showing up here, but it's two words, priming, phonological. But there was a little trick built in, so it's actually phonological priming, and I'm sorry you cannot see it. So in Russian, milk is молоко, and that's the first word you see. And the second word is молоток. Молоко, молоток. Молоток actually means hammer, and it's Levenstein distance of 2. So what we try to do, we use a translation judgment manipulation, which is, I guess, a variation of a priming methodology. We replaced the translation for the similar sounding word. So молоко, milk, or молоко, hammer, which would be a mismatch. So translation judgment, is it the right translation of the word or not? Oh, here we go. I'm sorry about that. I guess it was all here. There we go. So those are the results. We tested three groups. We have native speakers on the left. You have superior in the middle and advanced on the right. So the proficiency goes low proficiency to native speakers, so from right to left. In red, that's the high frequency words. In blue are the lower frequency words. And what you see in those red lines, this is the sensitivity to high frequency words as a function of proficiency. If you compare, especially in the advanced group, in the C section, you can see that sensitivity to low frequency words is pretty straight, and that's about like the same across everybody because the words are not well known. But the high frequency words, advanced learners, they tend to confuse the words up to 2 positions, Levenstein distance apart. So while native speakers only really confuse 1 Levenstein distance, and then, so you see, like the control is on the left, the little square. So you see the difference between, like in the native speakers, there's a little bit of a difference. They can get confused as well. But the difference gets larger in the superior learners, and then in advanced, you see that huge gap that they heard the wrong word. Well, they think they heard the wrong word. So what that means is that at the beginning, well, although they're advanced speakers, so they are advanced speakers, but even at the advanced stages of proficiency, they confuse high frequency words that they know very well. But just because their representations are not fine-grained, up to 2 phonemes can be different, and they're still accepted for the word that wasn't intended, for a phonologically similar sounding word. So what we also know about phonological representations, actually how the whole concept and the theory started was from phonological priming. And what we noticed was that in phonological priming, the effect is completely reversed in non-native speakers. So in native speakers, you would accept, typically you expect a word inhibition and non-word facilitation. So it's the opposite effects. So we tried to see what would happen in Russian speakers. So we took 2 groups of speakers, well, native speakers and non-native speakers, and I wanted to see how did they do the priming experiment. And what we see is exactly the same, the reversal of the priming effect in the low frequency condition. If you can see, there's, so unrelated primes are, yes. Yep. It's the difference So they're actually showing inhibition, right? I'm sorry, I'm a little confused myself. I haven't looked at this. What is it? Is it high frequency, interaction, phonological priming, high frequency, low frequency condition? Yeah, so yes. Is it semantic? I'm so sorry. Phonological priming. Let's keep it. We'll come back to this. So what we'll also know is that because of confusion of forms, word with similar phonological form are activated by the competitor's semantic associate. So it leads to incorrect and weak form to meaning mapping. So this is a second experiment from the same, I guess, cycle of research that we. So this is semantic priming in Russian, one language, and we manipulating the same words. So молоко and молоток. So if non-native speakers think that they heard молоко, which is a semantic priming, milk semantic priming to корова, the cow, then they have semantic priming. If they show semantic priming to cow and hammer, then we know they show semantic priming as well. That's not quite what we found, but what we did find was that the intermediate learners were a lot more confused. So there's a little bit of a delay, which is actually in line with some of the recent research about lexical consolidation of newly learned words. So if the words are not very well known, they can show longer priming effects, and especially for semantic priming. Okay, let's move on to the next. What we also found was that, and that's primarily based on the priming experiments again, that that fuzziness is actually related to proficiency as well. So the better the words are learning, the better the words are known to the learner, then the more native-like effects they're showing. So again, this kind of indication towards that developing lexicon. So at the beginning, it's one way, but it's gradually shifting towards native-like performance. So what we had was it's a phonological priming experiment, but in this case we manipulated that ISI, so interstimulus interval. For the one set of stimuli, we had 350, which is shorter, and a longer 500 interval. But most importantly, we controlled for the words. We made sure that the learners actually know the words, and if they don't know the words, we wanted to see what they do with those words. So after the experiment, the priming experiment, which was online measuring reaction time, we also administered a written test, how well the students actually know the words that they saw in the priming experiment. And they were asked to translate the word from Russian into English, give an English equivalent, and then rate whether they think the word, like they know this word, I think I know this word, or I recognize the word, or I don't know the word. And this is what we got. If you look at the well-known words at shorter ISI duration, you see a very clear semantic effect. But all the effect kind of washes itself out if the words are not known or if they're just recognizable, so there's no contact with the semantics. What is even more telling is that there's no semantic effect at all in the longer ISI. And that was one of the questions we asked. Why wouldn't learners show semantic effect? Because if lexical access is slower, right, then they should be showing a delayed semantic effect. But there's also another possibility, that maybe 500 ISI is too long. And although it may work for, like really, really beginner learners, but it didn't work for us, because there's a possibility. So the priming is based on, keep in mind that it's 2 activations. It's not just one. It's not lexical decision. So you have one activation for the prime, and the activation for the target has to overlap the activation, build on the activation for the prime. If this activation of the prime, and we know it's there because we see the semantic effect at short ISI, so there is an early, let me just, take the short and the long distinction with a grain of salt, because this is actually pretty long intervals, even for non-native speakers. Typically, the interstimulus intervals somewhere like in the hundreds, like 50 milliseconds, 100 milliseconds. So those are pretty long intervals. So we do see semantic priming. So the learners do activate the prime and the target, and they show very similar semantic effects. Everything is fine. But what is probably happening with the long ISIs, the activation they get is not sufficient enough. They cannot retain it. So there's nothing, with the longer ISI allows the first activation of the prime to dissipate, and then the second activation, there's nothing to build on. So it's just there. So, and we kind of decided to test that. The hypothesis was, if this activation is low, slow, and inconsistent, then a lot, the neighborhood may be activated. Or in this case, we're looking at the cohorts, which I think is a better approximation for auditory perception, because it's the word unfolds on the timeline, right? So you start with the first syllable, and then you hear it this way. So if there is a mismatch in the initial syllable, that really, it's as it's possible for neighborhood, for a word to be included in the neighborhood if there is a mismatch in the initial syllable. It really wouldn't work in this scenario because it's auditory priming. So for native speakers, an effect that's expected is from overlap of one phoneme is facilitation, overlap of 2 initial phonemes is nothing, and overlap of 3 phonemes, this is the initial, kind of the first step for phonological inhibition. For native, that's the predicted effect. So if our native speakers have that very slow activation level, very slow access to the words, are they able to resolve that competition? If the activation is so slow and the competition is just, they're not at the level to compete like the words would do in the native speakers, then we would expect to see a sublexical or prelexical activation. So the entire neighborhood was activated. And typically in the native speakers, you would expect a facilitating effect from the neighborhood, or also a phonotactical facilitation, because there's that large neighborhood, and this is a typical, like a good start, a recognizable start for a lot of words in the lexicon. But if you have a small neighborhood, then you don't have that. You don't have that, the backup. And so in this study, we compared 2 groups, intermediate and advanced group. And we calculated the size of neighborhood based on their estimated lexicon sizes. And what we see is that the reason intermediate group is really not showing, if we collapse those 2 conditions, we'll see no effect. But advanced group will show the effect of small cohort. So it's really, the absence of an effect is not because they're not sensitive, the non-native speakers are not sensitive to phonology. It's just because they take advantage of the size of the neighborhood differently. So for non-native speakers, you actually expect facilitation from the size of the neighborhood, just because there's no final competitor selected, and they all remain active. And that's why there is speed up due to phonology. So why do we think this is the case? So you'll see on the left are the native speakers, and on the right you see non-native speakers. So when you think about the neighborhood and neighborhood sizes, for non-native speakers, if they hear the word parrot, they would be quite comfortable, activating the appropriate phonological representation and accessing the semantic of it right away. It's very straight, direct. But in the non-native speakers, those two concepts at the beginning stages of acquisition may be conflated or may be neutralized. So parrot may be neutralized in favor of parent. So when the learner hears parent and they're not familiar with the word parrot, it's just that the phonological confusion exists. If they hear parrot, it may be heard as parent. And then both directions are activated. So you have the neighborhood of the, not the neighborhood, but semantic field of children and family, because it's associated with parent. But then you also have the neighborhood of birds, because parrot is a bird. So that activation is kind of dispersed across two different fields, right? First, one reason is because those two phonological representations between parent and parrot are not differentiated enough. So they can, in some instances, they can be co-activated. And that's one of the possible scenarios that how we can explain the lexical confusions that arise in a developing lexicon. So I've started with kind of talking about the differences between L1 and L2, but I also want to mention that there are a lot of similarities between L1 and L2 in terms of how we interpret fuzzy lexical representations. And I'm not going to go through this, but there's different avenues, different directions of research that point in the same direction. So it's not specific to L2, but it's a property. Fuzzy lexical representation is a property of a developing lexicon, and if the lexicon is not 100% developed, like for example, I mentioned in non-proficient readers in L1, it can also demonstrate the same features as a developing L2 lexicon. So I just wanted to thank you for listening, for your attendance, and I actually there's a couple things to mention about future directions. What are, in my opinion, possible areas of research? So is there something? Is there cognitive? What are the cognitive factors that are involved in this? So if we're talking about lexical competition, then cognitive control and inhibition control should be involved, right? So is it something that we can train, or can we account for it? Can we at least see if there is any correlations or any parallels between the two? And also, what other factors could be involved? If it is cognitive control, great, but if it's not, are there any other factors? So I think we just need to look into more lexical parameters, lexical features, and see if we can find a different explanation. So for now, this is in my belief, is the answer. So it's just the non-native speakers, they're refining their phonological representation, and I'm sure there are cognitive factors involved, individual differences, and it would be interesting to know which factors are. And I'm sure there are lexical factors that are involved. So we know that frequency is a factor, individual word learning experience is a factor, lexicon size, cohort size, or neighborhood density is also a factor. Is there anything else? So that's all I have. Thank you very much. I welcome questions.